Next property we are going to see of transition element is the color of transition elements. Most of the ionic and covalent compounds formed by the transition elements are colored. Any substance absorbs the light of particular wavelength from the white light or visible light and emits the light of remaining wavelength, and that substance appears colored. The color of that substance is due to the emitted light and not due to the absorbed light. But means if any substance absorbs the red light, then it emits the blue light, and color of that substance is the blue. Then how that substance or transition metals absorbs the light? Transition elements contains mostly the unpaired electrons in n-1 d orbitals, and in case of neutral atom, all the d orbitals are degenerated. Means we know all the higher d orbitals are degenerate, that they have the same energy. But this is in case of neutral atom. If that element or that atom for the compounds, then in case of complex compound, the degeneracy of this d orbital is lost, and there is a formation of the two sets of these d orbitals, T2g set and Eg set, dxy, dyj and dxj, and this is dx square minus y square and dz square. See again, the d orbitals have the same energy but in the neutral or ground state. But when that elements forms the complex compounds, and degeneracy of that d orbital is lost, and there is a formation of the two sets of the d orbitals, one with the lower energy which is called as the T2g sets. There are the d orbitals, three orbitals, dxy, dyj and dxj, and another is the set of two orbitals, Eg set. Orbitals are dx square minus y square and dz square. This is with lower energy, this is with the higher energy. When unpaired electrons are paired in n-1 d orbital of any transition element, if there are unpaired electron, then that unpaired electron when absorbs the energy, it promotes or transits from lower energy orbital to the higher energy d orbital by the absorption of energy. And when it comes back again to the lower energy orbital, it emits the radiations of particular wavelength, and color of that complex compound in solution form or solid is due to that emitted light. Thus, when there are unpaired electrons, the electron can transfer from one d orbital to another d orbital, and the color of the transition metal ions or compound is mainly due to d transition. And its main reason for the color of the transition metals is the d transition. If there is any one unpaired electron, then there can be d transition possible. But if all the d orbitals are completely filled, that is, there are all the d orbitals are paired, then there is a d transition is not possible, and hence which are colorless. Means if electronic configuration is 3d0, then that complex is colorless, because d transition is not possible. If electronic configuration of that ion is 3d10, then the d orbitals are completely filled. Then also electronic configuration of that ion is 3D10, then it is colorless. If electronic configuration of that ion is 3D0, then colorless, 3D10, then also it is colorless. These compounds are colored when there is a number of unpaired electrons are present in the d orbitals. Means the color of the 3D series is mainly due to the D transition. Color of metal ions also depends on nature of ligands and geometry of molecules. Color is mainly due to the transition, but also it depends on the ligands. What is meant by ligands? Ligand means the number of molecules or the atoms or ions surrounding the central metal atom. If this is a central metal atom, then what atoms or ions surrounding the central metal atom, suppose X, Y, Z, or these surrounding atoms, ions or molecules are the ligands, and color of the transition metals depends on this ligand as well as the geometry of that molecule. How it depends? If when cobalt chloride is COCl2, cobalt chloride is dissolved in water. This is a cobalt chloride. If it dissolved in water, there is a formation of the complex COCH2O. COH2O6 2 plus. This is the cobalt, small o, COH2O6 2 plus. When cobalt chloride dissolved in water, there is a formation of this complex, and this complex has this formation of the pink color solution. Here H2O molecules are the ligands. This is the central cobalt. This is called as the ligands. And its structure of that complex is the octahedral. And color is pink. When this solution is treated with concentrated HCl, if this COH2O6 2 plus, this complex is treated with the concentrated HCl, there is a formation of the cobalt COCl4 2 minus new complex, and which shows the blue color, and it is tetrahedral. Thus, see again, when cobalt chloride is treated with water or dissolved in water, there is a formation of this complex COH2O6 2 plus. This complex has the pink color and its geometry is the octahedral. It has pink color, but when it is treated with concentrated HCl, there is a formation of the complex COCl4 2 minus, which has the blue color. It has the pink color, it has the blue color. Which colors are the different? These are complex of the same metal, that is the cobalt. The colors are the different. Why? Because this color also depends on the ligands. Here ligands are the water molecules. Here ligands are the chlorine atoms. And hence, as ligands are the different, the color is different. Here geometry of this complex is octahedral, and here geometry is tetrahedral. That means the color of the transition metals depends on the geometry of that molecule as well as the nature of ligands of that molecules. Thus, color of transition metal ions related to or depends on which factors? Then first is the presence of unpaired d electrons. If there are presence of unpaired d electrons, then d transition is possible. If there are not presence or absence of unpaired d electrons. If all d electrons are paired or there is no any d electrons, then d transition is not possible. And which are the colorless, means color depends on presence of unpaired d electrons, d transition, nature of the ligands attached to the central metal ion, as well as the geometry of the complex formed by the metal ion. One more factor, color of the transition metal ions also depends on the charge transfer. The dichromate ions Ar2O7 2-, chromate ions Ar04-, cuprous oxide Cu2O and nickel DMG complex can be, color of these complexes can be explained through the charge transfer transition. Thus, color of the transition metals due to charge transfer transition also. We are going to see some colors of the transition metal ions. How to find the color? Consider the one ion scandium 3+. Then what is the outer electronic configuration of this? As it is the first element of the 3D series, atomic number 21. Electronic configuration of outer electronic configuration is 3d14s2, right? Because atomic number 21. Scandium plus 3 ion means there is a loss of the 3 electrons. All the 2 electrons from 4s and 1 electron 3d are lost, and the configuration becomes 3d0. 4s 0 outer electronic configuration. How many number of unpaired electrons in d orbitals? Unpaired electron कितने हैं? There is a 0 unpaired electron. As there is a 0 unpaired electron, this Sc plus 3 means compounds in which Sc plus 3 ion is present is colorless and not colored. Then we see the Ti plus 3 ion, titanium plus 3. Titanium second element, atomic number 22, electronic configuration 3d2 4s2. In Ti plus 3 is loss of the 3 electrons, loss of this 2 plus this 1, this configuration becomes 3d1 4s0. How many number of unpaired electrons? There is only one unpaired electron. As there is only one unpaired electron, means d transition can possible, and hence it has the color, and which has the purple color. Then Ti 4+. This is the configuration of the 3d2 4s2 Ti 4+. Means all the electrons from 3d and 4s are lost. As all the electrons are lost, it becomes 3d0 4s0. It becomes 3d0 4s0 of outer electronic configuration of Ti plus 4. How many number of unpaired electrons? No unpaired electron, no unpaired electron, unpaired electron 0, and hence Ti plus 4. Color of the Ti plus 4, hidden transition not possible. Color is colorless. If we consider another, that is the vanadium 3+. Vanadium 3+. Vanadium. And what is the atomic number of vanadium? Science teacher invented video. That is the vanadium atomic number 23. What is the electronic configuration? As atomic number is 23, it is 3d3 4s2. Vanadium 3+. That means the loss of these 2 electrons and this 1 electron, 3 minus 1, 2. This electronic configuration becomes 3d2 4s0. How many unpaired electrons here? 2 unpaired electrons. If 2 unpaired electrons, there must be any color, that is the green color. This is the green color. Similarly, we can find out whether that compound is colorless or colored. We can see the zinc. Zinc is the last element which has only one oxidation state, that is Zn+2. Zinc 30, atomic number is 30, configuration is 3d10 4s2. As it has only one oxidation state +2, this is 2 electrons are lost, therefore configuration 3d10 4s0. How many unpaired electrons? There are 10 electrons in 3d orbital, but there is no any unpaired electrons because all the 3d orbitals are completely filled. These unpaired electrons are 0, and hence Zn+2 is a colorless. Thus, for any element in their particular oxidation state, we can find out whether that compound is color or the colorless. You can see the colors of different cations from the book. And next,
start.
Thank you. We are going to see the another properties in next lecture.